Here's a question that often trips up even experienced analysts. After fitting your regression model, you notice prediction errors are small for low value transactions but huge for high value ones. Why is that a problem? What you're seeing is heteroskedasticity, a fancy word that simply means your errors don't spread evenly across predictions. In a perfect world, the model's mistakes should be roughly consistent, whether you're predicting small sales or massive ones. But when residuals start to fan out as predicted values increase, it signals non-constant variance of errors. On the chart, notice how the red pattern widens like a funnel. That's heteroskedasticity in action. Now, here's the key. Your model can still make decent predictions, but your standard errors become biased. That means your p-values and confidence intervals, the tools you use to test significance, are no longer trustworthy. In other words, you might think a variable is significant when it's not. That's dangerous in business decisions, especially when you're estimating things like revenue growth or investment risk. So remember, heteroskedasticity doesn't kill your model's accuracy, but it breaks your ability to trust how confident you are in its results. Okay, so now you've spotted that widening funnel in your residuals. What do you do about it? First, you detect it formally. Plot your residuals versus fitted values. If you see a cone or fan shape, that's your visual clue. For statistical confirmation, you can run tests like the Bruch, Pagan, or White's test. Next, you fix it, and there are a few solid approaches depending on your goal. If you want to stabilize variance, apply log or square root transformations to your outcome variable. If you just need valid inference without changing your coefficients, use robust standard errors. These adjust for heteroskedasticity so your p-values stay reliable. And if you want to directly handle the issue in modeling, try weighted regression or observations with SEN. You can engine your product online following cache with 1K, 2, and 3 FAS. Here's how you could confidently summarize this in an interview. You will send a fine following product if you find your product online. Here's how you could confidently summarize this in an interview. Heteroskedasticity means non-constant error variance. Residuals fan out or compress across predictions. It makes standard errors unreliable, distorting p-values in confidence intervals. I detect it using residual plots or Bruch-Pagan tests, and fix it using log transformations, robust standard errors, or weighted least squares, depending on whether I need more accurate inference or better predictive stability. That answer shows you understand not just what heteroskedasticity is, but why it matters, both statistically and in business.